All right, so Chapter 8, Section 2, let's look at a few problems. Kind of looking at hypothesis testing in this section. Um, so make a decision about a given claim. Do not use any, so no procedures or exact calculations, and the rare event rule. That's something that's in your section from 8.2, so make sure you look at the reading on that. And that just says if something's unlikely that it occurs, then maybe something's off. Um, so it's a rare event. If the probability is low, then maybe something's not true about what is known. So here's a claim: a coin favors heads when tossed, and 19 heads out of 22. So no crazy calculations, but if we did maybe a 19 divided by 22, um, that's a lot more than 50%, and that's what we think a fair coin would be. So there does not appear to be sufficient evidence to support the claim because there are substantially more heads than tails. Not sure if I believe that. There does appear to be sufficient evidence. Yes. So a coin favors heads because there's more heads than there are tails. So that makes sense. Next one I want to look at is number 6. So number 6 is asking to find a test statistic. So the claim that white blood cells counts of an adult female normally distributed with a standard deviation equal to 2.54. So they're telling us what the known standard deviation is. A random sample of 41 adult females has white blood cell counts with a mean of that and a standard deviation of that. Find the value of the test statistic. Well, first we have to figure out what are we trying to find the test statistic for. Is it means? Is it a proportion? Is it a standard deviation? Since they've given us a known standard deviation, and here's our sample standard deviation, this is leading us to say, hey, I need to be looking at determining if the standard deviations are the same. So, similar to the last section, if we want to find information about the standard deviation, we'd be looking at, I think we used the calculator for maybe a chi-square, but also under variance stats, we looked at doing confidence intervals for the standard deviation or variance. So we have some information to put in. Now we know the sample size is 41, but I don't know what the sample variance is. I know what the sample standard deviation is. So to find out the sample variance, I'm going to square it, because that's how we get variance, is by squaring the standard deviation. So I also need to figure out what the hypothesized variance is. So that's this 2.54. So again, let's square it. And 6.4516. And it doesn't say less than or greater than anywhere, so we're going to assume that it's a not equal to. Now the test statistic is going to come up here. This is our test statistic. Whether we're using a t-stat, a proportion stat, even sometimes a norm stat. This is our test statistic. This is our p-value. So with the p-values, we'll deal more in the coming sections talking about how we make our decision about a claim, our null hypothesis. So my test statistic is this 84.3 decimal places. So 84.420. Another question I want to look at is number 8. So on this one, assume that the significance level is 0.05. Use the given statement to find the p-value and critical values if we have a test statistic of negative 1.59 is attained when testing the claim that p equals 1/3. So we're dealing with proportions. We know that proportions, we're going to use a normal calculator. And so if I just wanted to find what my p-value was, I know the test statistic is negative 1.59. So let's plug in negative 1.59. And this is going to give me the area to the left, right? So I get 0.0559174. Now, calculating p-values off of a test statistic sometimes can be a little nutty. If this is a not equal to issue, a not equal to alternative hypothesis, then we actually have to calculate the area to the left and the area to the right. So if I take that number, that 0.0559174, and I double it, because I'm going to have the same amount of area on this right side in a not equal to. It's kind of like with a confidence interval, you had things to the left and to the right. This one does not say that it's strictly left or strictly right, and so we would need to double that p-value. And that's kind of the trick on these, is if it's a not equal to, it's the area to the left and to the right. So we would just double that percentage underneath the curve. The critical values, so if I have a 5% alpha, I'm looking for when is there 2.5 on the left and to the right. So the total sum from here is 2.5%, and the total sum for here is 2.5%. So this negative 1.96 and positive 1.96, they said, so negative 1.960, comma, and 1.960. Those would be my critical values. So any test statistic past these values, I would think that's very rare that would happen. This 11% that we have is not that rare. One more question to look at is number 11. Again, make sure you do the reading in this section. Specifically, there's some definitions. A type 1 error. A type 1 error is when you reject the null hypothesis when you shouldn't have. The null hypothesis is actually true. So, which is a type 1 error? You need to use that definition in this. Identify the type 1 error and the type 2 error that corresponds to the given hypothesis. So we'll do the type 1 error. So it's when we reject the claim when it's actually 0.23. So that would be a B choice. Now, for a type 2 error, it's when we don't reject the null, but we should have. So that should help you out with the part 2.